Inner Earth Discovery. What truly lies beneath our feet? We're taught it's a simple, layered model, a crust, a mantle, and a core. It's the bedrock of geology, a truth cemented in textbooks and classrooms for over a century. But what if that model isn't just incomplete? What if it's fundamentally wrong? What if the greatest secret of our world isn't in the distant stars, but is instead grinding away, silently, thousands of miles beneath the surface we call home? This is the story of a discovery so profound it threatened to shatter our understanding of everything, and of the brilliant woman who found it, Dr. Aris Thorne. Her journey didn't begin with a quest to overturn science. It began with a simple academic pursuit to see the unseen. Dr. Thorne was a geophysicist, but she wasn't just any geophysicist. She was a prodigy, a visionary in the field of seismic tomography. While her colleagues were refining existing methods, Thorne was inventing entirely new ones. She developed a technique she called quantum resonance mapping, a revolutionary approach that didn't just listen to the echoes of earthquakes as they passed through the planet. It analyzed the subtle, quantum-level vibrations of the Earth's own structure. Imagine the planet as a colossal bell. An earthquake is the strike, and traditional seismology studies the main dong as it reverberates. Thorne's method, however, listened for the hum. It analyzed the faint, harmonic overtones that other systems dismissed as mere noise. To do this, she built a network of hypersensitive sensors, deployed in the deepest boreholes and the most remote corners of the globe, all linked to a proprietary quantum computer she had helped design. The processing power was immense, capable of rendering the planet's interior with a resolution previously thought impossible. For 2 years, the system gathered data, building a picture of the Earth's mantle and core with breathtaking clarity. And that's when the anomaly appeared. It wasn't a sudden event. It was a persistent, undeniable whisper in the data, a ghost in the machine. Deep within the lower mantle, roughly 2,000 kilometers down, her system was mapping a structure that simply shouldn't have been there. At first, she assumed it was an error, a bug in her code, a sensor malfunction, solar interference. Anything and everything was a more likely explanation than what the data was showing her. She spent 6 months trying to debunk her own findings, running diagnostics, recalibrating the entire network, and rewriting algorithms from scratch. Yet, with every iteration, the image only grew sharper, more defined. The anomaly was real. It was a distinct, near-perfectly spherical object, approximately 3,400 kilometers in diameter, just a little smaller than the planet Mars. And its characteristics were utterly baffling. Its density was significantly higher than the surrounding mantle, closer to that of a solid iron-nickel core. It exhibited its own faint magnetic field, entirely separate from Earth's primary field generated by the outer core. Most shocking of all, her resonance data suggested it was rotating, but at a slightly different rate than the rest of the planet, a phenomenon of differential rotation that defied all known geophysics. This wasn't just a denser layer or an unusual mineral formation. The evidence was overwhelming. This was a separate, distinct planetary body, nested inside our own like a Russian doll. A planet within a planet. Dr. Thorne named it Chthoniya, after the Greek deities of the underworld. She knew the implications were staggering, but as a scientist, her duty was to the data. She triple-checked her work, wrote a meticulously detailed paper, and submitted it to the world's most prestigious geophysical journal. The initial reaction was electric. The community buzzed with a mix of disbelief and intense curiosity. Her name was on everyone's lips. She was invited to present her findings at the Global Geological Symposium in Geneva, the pinnacle event in her field. She stood before the titans of science, her heart pounding, and laid out the evidence for chthoniya. The room was silent, captivated. For a moment, it felt like a triumph. She had peered into the heart of our world and found a secret universe. But the shift, when it came, was subtle at first. A few skeptical questions at the end of her presentation, a polite but dismissive article from a tenured professor suggesting more conventional explanations for her data. Then the peer review for her paper came back. It was brutal. Reviewers who had previously praised her methods now called them unorthodox and prone to systemic error. They demanded a level of proof that was practically impossible without a multi-trillion-dollar drilling project. The excitement curdled into suspicion. The problem was that her discovery didn't just add a new chapter to the geology textbooks, it demanded they all be thrown into a fire. It violated the standard model of planetary accretion. It challenged fundamental principles of gravity and mass distribution within the Earth. It opened a Pandora's box of questions that the establishment was not prepared or willing to answer. The data was too radical, too paradigm-shattering. And as Dr. Thorne refused to back down, as she defended her data with the fierce passion that had driven her to this point, the establishment found a new target. If they couldn't attack the data, they would attack the scientist.
Science gender bias. The resistance to Dr. Thorne's discovery didn't begin as a coordinated campaign. It started as whispers in the hallowed halls of academia, as dismissive remarks over coffee at conferences. The science was complex, the data revolutionary, so the attacks took a simpler, more insidious route. They targeted Aris Thorne herself. The very qualities that had defined her as a brilliant and driven scientist were suddenly reframed, twisted into character flaws. Her unwavering confidence in her meticulously gathered data, that was now labeled as arrogance. Her passionate defense of her work in the face of criticism, that was respun as being overly emotional. Her refusal to bow to the pressure of senior male colleagues who urged her to reevaluate her outlandish conclusions, that, most damningly of all, was what made her difficult. The difficult woman trope is one of the oldest weapons in the arsenal of institutional power. It's a subtle, effective tool of character assassination designed to dismiss a person's contributions without ever having to engage with the substance of their work. A man who is persistent is called determined. A woman who is persistent is called stubborn. A man who is certain is called a leader. A woman who is certain is called dogmatic. For Dr. Thorne, this was a bewildering and painful new reality. She had spent her life in the objective world of numbers, physics, and data. She believed that evidence was the only thing that mattered. She was naive to the fact that science, like any human endeavor, is rife with politics, ego, and deep-seated bias. The campaign against her escalated methodically. Her research proposals for further study into the Thorne anomaly, as it was now dismissively called, were rejected one after another. The anonymous feedback from grant committees was a masterclass in coded language. Her proposals were too speculative, lacking a firm theoretical grounding. A classic catch-22, as no theoretical grounding existed for something that had never been discovered before. Funding for her lab, once plentiful, began to dry up, forcing her to lay off junior researchers and scale back her operations. Then came the professional isolation. Invitations to speak at major universities ceased. Colleagues she had once collaborated with would now avoid eye contact in hallways. She found herself unceremoniously removed from committees and editorial boards. A prominent figure in the field, a man named Dr. Alastair Finch, who had built his entire career on the standard model of Earth's interior, became her most vocal critic. He never directly refuted her raw data in public. Instead, he skillfully sowed seeds of doubt about her judgment. In an influential op-ed, he wrote, "While Dr. Thorne's technical skills are noteworthy, her rush to fantastical conclusions speaks to a lack of scholarly restraint. True science requires patience, not publicity." The message was clear. She wasn't a real scientist, she was a reckless sensationalist. This narrative was incredibly damaging, playing on centuries of prejudice that paints women as less rational and more prone to hysteria than men. It's a pattern seen throughout history. We remember Rosalind Franklin, whose crucial data was used without her permission to unlock the structure of DNA, while she was quietly sidelined, and her contributions only acknowledged decades later. We remember Lise Meitner, who co-discovered nuclear fission but was denied the Nobel Prize, which went exclusively to her male colleague. Dr. Aris Thorne was simply the latest in a long, tragic line of brilliant women whose work was too inconvenient for the men in charge. The personal toll was immense. She faced a barrage of online harassment, her email inbox filled with vile misogynistic messages. She suffered from sleepless nights, rereading her data again and again, wondering if she was going insane. The establishment wasn't just telling her she was wrong, it was trying to make her believe it herself. The climax of this campaign occurred at a symposium in Boston. Dr. Finch was the keynote speaker. He dedicated a significant portion of his speech not to presenting new research, but to a thinly veiled takedown of Thorne's work. He called it a cautionary tale of how sophisticated technology can lead to sophisticated delusions. He never said her name, but everyone in the auditorium knew exactly who he was talking about. He put up a slide with a complex seismic graph from her paper, circling a tiny data point and calling it the seed of a grand fantasy. The audience, mostly her peers, chuckled. In that moment, she was officially excommunicated from the Church of Mainstream Science. She was no longer a pioneering researcher, she was a punchline. But as she sat there, listening to the laughter, something inside her hardened. They could take her funding, they could ruin her reputation, they could label her whatever they wanted. But they couldn't take away her data. And they couldn't take away the truth. The question of what lay deep within the earth was no longer just a scientific puzzle, it had become a battle for her very soul. And it was a battle she had no intention of losing. The personal toll was immense. She faced a barrage of online harassment, her email inbox filled with vile misogynistic messages. She suffered from sleepless nights, rereading her data again and again, wondering if she was going insane. The establishment wasn't just telling her she was wrong, it was trying to make her believe it herself. The climax of this campaign occurred at a symposium in Boston. Dr. Finch was the keynote speaker. He dedicated a significant portion of his speech not to presenting new research, but to a thinly veiled takedown of Thorne's work. He called it a cautionary tale of how sophisticated technology can lead to sophisticated delusions. He never said her name, but everyone in the auditorium knew exactly who he was talking about. He put up a slide with a complex seismic graph from her paper, circling a tiny data point and calling it the seed of a grand fantasy. The audience, mostly her peers, chuckled. In that moment, she was officially excommunicated from the Church of Mainstream Science. She was no longer a pioneering researcher, she was a punchline. But as she sat there, listening to the laughter, something inside her hardened. They could take her funding, they could ruin her reputation, they could label her whatever they wanted. But they couldn't take away her data. And they couldn't take away the truth. The question of what lay deep within the earth was no longer just a scientific puzzle. It had become a battle for her very soul. And it was a battle she had no intention of losing.
Block 3. Forbidden Planetary Science. To be publicly humiliated and professionally exiled would break most people. For Dr. Aris Thorne, it was a liberation. Stripped of her funding, her reputation, and her access to the gilded halls of institutional science, she was finally free. free from the politics, the peer review committees, and the crushing weight of dogma. They had tried to silence her, but they had only succeeded in making her more dangerous. She was no longer trying to convince them. She was now working to prove them wrong, on her own terms. Dr. Thorne retreated from the public eye, cashing in her retirement funds and converting the top floor of her home into a makeshift research lab. She became a ghost in the scientific world, but her work was more intense than ever. She knew she couldn't compete with the resources of major universities, so she became smarter. She leveraged publicly available seismic data from global earthquake monitoring networks, developing new algorithms to filter and analyze it, hunting for further echoes of Thonia. She also built a new, clandestine network of collaborators. They were the other outcasts and mavericks of the scientific world. A disgraced theoretical physicist who had published papers on multidimensional gravity. A young, brilliant data scientist who believed in open-source research. And an elderly, retired geologist who had harbored his own quiet doubts about the Standard Model for 50 years. Communicating through encrypted channels, they became a secret, invisible college, dedicated to exploring the science deemed too forbidden for the mainstream. And the questions they pursued were some of the most profound imaginable. What would a planet inside Earth actually mean? The implications were staggering, branching out into every field of science. In physics, it was a nightmare and a paradise. How could two massive planetary bodies coexist, one nested within the other? Thorne's team theorized that Thonia might be composed of exotic, ultra-dense matter, creating a complex gravitational relationship that stabilized both bodies. The boundary between the Earth's mantle and Thonia's surface, a region Thorne called the heliopause, would be a place where the laws of physics as we know them might break down. A zone of unimaginable pressure and temperature where new states of matter could exist. Then there were the geological and resource implications. What was Thonia made of? If it was the core of a much older captured planet, it could be a treasure trove of heavy elements, metals so rare they don't even appear on our periodic table. Accessing these resources would be impossible with current technology, but their very existence would ignite a new global race, dwarfing the space race and the scramble for fossil fuels combined. The power to control such resources would redefine global economics and geopolitics forever. Perhaps this, Thorne mused, was the real reason the establishment was so terrified of her discovery. It wasn't just about scientific pride. It was about protecting a fragile global order that could be shattered by the revelation of an entire new world of wealth and power sitting right beneath our feet. But the most tantalizing and terrifying question of all was about life. Could Thonia be habitable? Not on its surface, which would be a searing hellscape, but within. If the inner planet had its own internal heat source and a liquid core, could it support a biosphere entirely independent of our own? Life on Earth is carbon-based and dependent on the sun. Life on Thonia might be silicon-based, drawing energy not from light, but from intense geothermal and magnetic forces. An entire ecosystem, an entire evolutionary tree, completely alien to us, existing for billions of years in total isolation. The philosophical and existential shock of such a discovery would be absolute. It would prove that life is not a fluke, but a fundamental property of the cosmos, capable of flourishing in the most unlikely of places. It would be the single greatest discovery in human history. Dr. Aris Thorne never got to prove her theory to the world. She passed away quietly, her work known only to a handful of followers and dismissed by the wider world as the obsession of a brilliant but troubled mind. Yet her legacy endures. Her papers, once ridiculed, are now passed around on the internet, inspiring a new generation of geophysicists to look at the data differently. Strange seismic anomalies, once dismissed as noise, are now being quietly re-examined. The Thorne anomaly persists, a stubborn ghost in the planet's deep interior, a question mark hanging at the very center of our world. Her story is a chilling reminder that some truths may be deemed too inconvenient to be known, and that scientific establishments can be just as dogmatic as any ancient religion. The quest for knowledge is always a struggle against the darkness, but sometimes the darkness is not ignorance, but the deliberate suppression of a light that shines too brightly. The truth is not always out there in the stars. Sometimes it is buried deep within, waiting for someone brave enough, or perhaps difficult enough, to dig.